here with you to share our experience in hyperconvergence. This presentation will not be a talk, an in-depth analysis about Proxmox or Ceph, but will be the story of our experience in hyperconvergence. So, what we are here to talk about? So firstly, I will introduce myself, my company, and what is hyperconvergence and how it is achieved. Then I will continue with the journey, with the story of our cluster from the beginning till the present day. And at the end, I will tell you what we learned about this journey and what are the next steps that are there are for us in the future. So let's begin to who, what, and where. So who am I? I am a Linux system administrator. I was working with Proxmox from 2011. I think that the first version of Proxmox that I used was 1.5 or something like that. It was very old. So in 2017, when I joined Elettra, I started to work with Ceph. And now I am in charge of the virtualization and storage infrastructure at Elettra, but my duties doesn't end there. So I am also responsible on HPC, sync and share services, something about networking, but basically everything you can think about, I'm doing it in one part or maybe in some part. So let's introduce my company. What is Elettra-Sincrotrone? Elettra-Sincrotrone is a multidisciplinary research center which is located in Italy, in the northeast part of Italy, near the Slovenian border in Trieste. So we are running two particle accelerators which produce synchrotron light. We have more than 30 beamlines and laboratories with different, which are researching different fields from nanoconstructions to biology. And the resources needed for these laboratories are very different and very complex. We are almost 400 people working at Elettra, and each year there are 1,000 visiting scientists which we host and which we will provide support. So what does hyperconvergence mean? Hyperconvergence is a software-defined IT infrastructure which includes on the same node virtualization and storage and network. Runs on of the shells, conversion of the shells systems, and multiple nodes can be clustered together. So let's start with the first brick of hyperconvergence, the virtualization, the hypervisor. What is Proxmox? For the people that doesn't know about Proxmox, Proxmox is a virtualization platform for provisioning a hyperconverged infrastructure. It allows the deployment of KVM, QEMU virtual machine, and LXC containers. It's based on Debian, but runs with Ubuntu kernels. Multiple Proxmox nodes can be clustered together. So why we choose Proxmox? First of all, it's open source, and it's very easy to install and configure. It provides also Ceph. It's integrated deployment and configuration of Ceph, and also have an integrated backup system, which is very good to have in this type of infrastructure. Also, it can be used as single node, and it works very well as single node. But the benefit of hyperconvergence is when you use it in a cluster. So more nodes can be clustered together, and so you can achieve other features like live migration of virtual machines, high availability of virtual machines, there is a method in Proxmox working with CoroSync, which provides which restart if a node fails, the virtual machines which were running on that node will be restarted in another node. So it's very good to have. And also, you can integrate Proxmox with other tools. You don't need it. So out of the box, Proxmox is useful by himself. So you don't need it. But if you want, you can use API to integrate in some automation and automated tools. So I will not introduce you Ceph. I think that in this venue, it's pointless to do that. So I will just introduce how we are using Ceph at Elettra. So the biggest cluster we have is a RBD cluster, which is a dedicated RBD cluster for our scientific data and applications. We are running 44 nodes, 600 and something OSDs. The majority of the OSDs are hard disk based. Virtualization is on a separate cluster, so it's just a dedicated Ceph cluster. But we also run 3 hyperconverged clusters. 2 smaller ones are for the control system of the accelerators, so they control the machines itself. Those 2 are 5 to 7 nodes big and are also deployed as a Proxmox plus Ceph clusters. The bigger one is 16 nodes. This cluster is hosts the company application like payrolls, documents, databases, and so on and so forth. They host also some core infrastructure services like DHCP, Active Domain, something. So it's a general purpose cluster which we are using for our mostly company-based, not scientific-based applications. And this cluster is also the hero of our journey. So we were talking about this cluster, this 16 nodes hyperconverged cluster. So let's start with our journey. It was in long time ago. It was a time when wooden stone were common, where there was a plethora of different servers. It was 2016. At that moment, we have a lot of physical servers with iSCSI storage, multiple single-node VMware servers, a couple of Xen and Proxmox clusters, and some single-node servers for scientific data storage. It was, let's say, not so homogeneous. It was very, very dispersed and very difficult to manage. So at certain point, somebody thought, okay, let's put something together. Let's try to find a way to end this mess. And a first cluster was purchased and deployed. The first cluster was just a cluster for just a cluster which have a Proxmox virtualization part and a dedicated Ceph storage, and that was thought to be the home for scientific data and applications. This was the beginning, but at the end, not everything was about to be run on that cluster, and so we still have a lot of different systems in the world, until it was a time when the 2 needs arise. Oh, sorry. So there are 2 needs arise when we need to update or upgrade in general, to change our current, not current, at the time, email system to a new one. So we chose to, we had two physical communicates mail servers with iSCSI storage, if I remember correctly, and we chose to migrate to Zimbra. This was one need that we have to fulfill. The other need was we need to have a computer-aided design suite based on CATIA and 3D experience. We need, which is something that we need to implement. And because of those needs, we finally had the budget to buy a new cluster. So a new cluster was purchased, an 8-node cluster based on Dell PowerEdge R1640, which has 20 cores in 2 sockets, 128 gigabyte of RAM, and some spinning disk. At the time, we thought the hard disk, spinning disk were enough for our purposes. We were wrong, but okay, you know. So we had the hardware, but what we want to do with that? So the rationale was we want to hyperconverge. We want to use all the nodes to have storage and virtualization on the same node to save also money, because we have a little budget, but it was not enough to have two things separated. So Proxmox was chosen as hypervisor because we already ran it. We were very good on it, and so it was very good for us. Ceph, strangely, was not the first choice. We evaluated other file systems, as like BGFS, Gluster, LizardFS, which at the end, for one reason or another, were not suited for our needs. So we went back to Ceph, as we should do it from the first time. Also because Proxmox has a direct support on it, so it was very easy to install. So we installed 8 nodes with Proxmox virtual environment 5.2. Then we installed with Proxmox, we installed Ceph. If I remember correctly, it was Luminous, but don't quote me on it because I don't remember exactly, but I think that was Luminous. And then we configure also, we installed Luminous, we configure a pool with a replica 4, because we don't want to lose my paycheck on my payroll, so it's something that it's very important for me. So I don't want to, so it's maybe too much. And then we also install and configure a CephFS file system for storing the emails of Zimbra suite. This second part was done manually because at the time Proxmox didn't support CephFS. Nowadays it's supported out of the box. So once installed, the day-to-day care was very easy. Proxmox itself is very easy to be managed, also for people who doesn't know about, who haven't the experience to use Proxmox. It's very, very, very easy. Disk failures are handled very well by Ceph, so we don't have any problem in that part. Once a year, most likely, we have to do system upgrades, which are very well documented, so it's very easy to do, and it's a very straightforward process. It's very easy to do it when you have live migration, so you can migrate nodes, then migrate virtual machine, upgrade the node, reboot, and continue with the next one. It's straightforward and usually doesn't have any problems until you find some problem. But the problems we found were only about some misconfiguration of our site, like we forget to do some network configuration on the switch or something like that. It was not, and it was easy solvable. But so after some years, we need more resources. So we bought new hardware. We double up the cluster from 8 to 16 nodes. In that moment, we also bought SSD finally to have something more fast for our data. In that case, we're SAS SSD, not NVMe. But at least it was one order of magnitude better than with HDDs. So in that moment, right now, we have 16 nodes, around 120 virtual machines running on it, 600 nodes, 600 cores, and 4 terabytes of RAM in total, and 150 terabytes of hard disk space and 240 terabytes of SSD space. But as I can tell you, not everything was running smoothly. So at the beginning of our journey, when the cluster was in its infancy, we have a problem, an incompatibility problem with Zimbra and CephFS. For unknown reason, once we moved all the emails on Zimbra, which was backend, which the CephFS was its storage backend, it worked until someday emails which were stored on CephFS and which were previously there. I saw it, so we were able to read it, we were able to access it, and were there, disappeared for reason that I cannot understand right now. Till now, I don't know what was going on. I think that was some problems between Zimbra and CephFS, but most likely some incompatibility issues in Zimbra, which didn't know how to handle something. So that was very worrying for us. And because of that, we decided to drop CephFS totally. We moved the data from CephFS in a RBD disk, mount the RBD disk to Zimbra, and then the problems didn't appear anymore. So yeah, I don't know what happened. We didn't have the resources and the time to investigate further. It's something that is still worrying me about CephFS in general, but maybe it's something that it's from myself, so it's not so. So apart from that, we have also problems with some temperamental virtual machines, which have, let's say that after some days after the machine were started up, the machines itself, it was getting very, very slow. LS takes 20 seconds, 30 seconds for in a very small directory. And at the end, we found that one of the culprits, or maybe it was that the disk of this virtual machine was on HDD pool. When we moved this on a SSD pool, the problem was resolved, and so we didn't see it anymore. Then I will say that in general problems, 90% of our problems with Ceph, with hyperconverged cluster was network related, like switches which had only one power supply, and once they were rebooted, lost the configuration, or rebooted without reason. And because how it's configured, Proxmox, which are using Chorus Sync to maintain the high availability in every node of Proxmox, there is a watchdog, which is, if it's not updated, will reboot the machine. So sometimes network-related problems can cause machine reboot. And this is very strange. We have also another problem when a configuration of a switch, which was wrong. was wrong in the sense that it was running, it was on the switch, but if you try to replicate, so try to redo the configuration from one interface to another, it was not yet possible to do that. But we don't know how it was possible in the first place because the configuration was there. So we were, okay, okay, something is wrong, and it was wrong configuration from beginning with. So we fix it, and this random reboot didn't occur anymore. Then we have also some broadcast storm. Well, this was this summer at certain point. It was not a broadcast storm, I will say, per se, because it was a strange behavior. We have a underlying network activity, but this network activity was consistent for 2 hours, and because the watchdog stuff, it started again to reboot nodes. So we decided to move the Proxmox and Ceph network out in a segregated VLAN, so that at least this problem will not come back. So I'm very fast. So let's go to the future and what the lesson we learned. So next steps. This year we have to update our cluster because the first 8 nodes are getting older, and the maintenance cost of these 8 old nodes, it's getting to the roof. It's something that we cannot afford. At least it doesn't make any sense to afford right now. So we buy 8 new nodes with another. We will almost double the core counts, almost double the RAM, and we add another 240 gigabytes of NVMe storage in that moment, because we can afford NVMe storage, and so we will buy NVMe storage. So the long-term, our long-term goal is also to remove the HDD, the spinning disk, and get all solid state. But it will take some time, at least another 2 years, I think, to everything. Another needs we have is create a RGWS-free cluster for object storage. This is not possible to do right now in Proxmox, because Proxmox doesn't support RGW in its deployment, and so it's most likely that it will be a separate cluster. And we will just run the virtual machines from that, the hyperconverged one. So, what we learned about hyperconvergence works. It's very proved to be highly resilient. Ceph was proved once again to be highly resilient. We had a very bad day when all our power supply, our power sources, because we have also a gas-generated power source in the house, went down. So we had to restart for cold all the infrastructure of Elettra. And once everything was up, everything was there, no problem at all. We didn't lose a bit, and this is very good. It is something that I can sleep in the night without a problem. So there are some caveats about hyperconvergence. If you are running your infrastructure on a hyperconverged cluster, you have to be aware that a cold restart can be tricky, because if you don't configure it right, you can end up in a loop of dependency loop, and it was more or less what we get last year. And at the end, we managed to get outside this loop, but nowadays we are decided to to set up a bootstrap node just in case it happens again. So it's very important that the cluster network is reliable. So network problems is the culprit of all the problems we had, and so you have to be very aware about network problems. It's usually a good idea to have Proxmox in a separate VLAN, and the most important thing is the resource management. It's easy to you have to leave resources for Ceph to do his stuff, so you cannot overcommit too much resources to virtualization. This is something that has to be done manually, because Proxmox doesn't have any type of right now at the moment doesn't have any type of resource quotas. So this is something that's it's easily if you are the only tenant of the cluster like we are, but I don't think that it's feasible if you have to have a multi-tenancy cluster. So also workloads are to be considered. Our cluster is mostly it's a low workload cluster. Does not have a lot of users, so we are not talking. We are talking about, I will say, 2,000 users in the same time, mostly the maximum. So for us, also some HDD-based machines are good, and because of that, we have also HDD. So clearly, if you want to get every IOPS possible, maybe a hyperconverged cluster is not ideal, but at least for us, it's working very well. So, thank you. Have you any questions? I don't see anything. You can go to the...
I was just curious, you mentioned the possibility of integrating Proxmox with other tools. There's an API for that. Is that something you have explored?
So we explored in some ways, yes. So I think that my colleagues in part of a project, they try to integrate Proxmox from something for provisioning virtual machines, basically. And it was possible, but because we don't have these quotas, it was very difficult to do it for different people than ourselves. This was possible. Okay. Other question?
Yes. Hello.
Yeah.
I'm a Proxmox developer, so I can have some question for you. For your network, do you use same NIC for both CoreSync and Ceph?
Yes, the fact is we did use two NICs. The problem was when we try to use the two rings. So, for example, one on the 1 gigabit network and the other one on the 10 gigabit networks. And on the 10 gigabit network, it was also the Proxmox stuff, the virtual machine and Ceph stuff. So it was just so. But we ran the problem that at the end, when the bigger switch, we had networking problem with the bigger switch. So one of the two rings failed. The other didn't. We have some strange behavior, and at the end, we dropped the two rings, and we just keep it one, because it was not something that we. So we set up something, and the end result was not what we was thinking of. I don't know what was the end result. It was not what we were expecting at the end.
I think the main problem currently is that there are no QoS, network QoS between CoreSync and Ceph protocol. So if you have network saturation, This is very, very, very bad for costing. And you can have some other.
I don't think that we have a high, our network consumption, it's very low, usually.
Be careful if you go to NVMe or something like that.
I know. We are, in general, nowadays, I didn't put it in the slide, we are upgrading our NICs to 25 gigabit per second, and we will use some network QoS and something like that. This is something that we are just thinking about, but it's not yet because we don't have the hardware right now.
Okay. And about Rados Gateway, if you want, you can install it on Proxmox, but command line. So.
Yeah, I know. I know that. It's just because of that, I think that we will install it as a Ceph admin cluster.
Yeah, you can do with Ceph ADM because you don't use a pod to deploy.
I am aware of that, and I just want to outline the future of our cluster, so it's not the same thing. Okay. But at the end, we are very positive about Proxmox, so I'm very, very fond of it.
Thank you.
Other questions? No? Well, thank you.